I welcome you to my lecture today. But before I go into my lecture today, I'm going to display the analysis of midterm one results. Actually, politicians will say election has consequences, right? As examination also has consequences. So this is the performance in midterm one: the minimum, the maximum, the median, and the mean. I'm going to say I'm not happy with this result at all because when I look at my 5101 for the 101, the average was far more than this. And I know why. The reason being that some students have not been attending lectures regularly, and maybe some students get stuck. They don't want to visit during the office hour. I will advise that if you get stuck, visit me in my office hour. My office hour starts from 11:30. You can see that on the syllabus. You may not necessarily need to come to me in person because I also hold it online over the Zoom. Just join my Zoom. Ask question about, maybe you may want me to clarify something. So I will advise that you ask me question. Let me just tell you the expectation in midterm 2. In midterm 2, exam is also going to be conducted online, where I'm going to the exam is going to be left open for some hours, just like the way I did in midterm 1. But you're actually going to log on to Zoom, where you're going to turn on your video. I'm not necessarily going to be there, but it will be recorded automatically. Does that make sense? That's what I'm going to do in midterm 2. So I'm appealing to everyone once again. If you get stuck or you are struggling in this class, please reach out to me. My office hour starts 11:30. I've been in office hour and I've not been seeing students. You know those students I'm seeing? Those students from my other classes. 5101 for the 101. I've not been seeing students from this class. And my intention, my belief before was, oh, everything was good. That was why they did not visit. But with this result, then everything is not good. Because I don't count the mean performance, having a mean performance of 84.86. As for me, that's bad. And if there's anything that you know that affects you in the exam, I want to hear from you. Send me a message. Okay, I want to go into another statistical topic. Can those of you online, can somebody confirm if you see? Are you still hearing me, right?
Yeah, we
Sure.
can see and hear you. Sorry about being late as well.
Okay, thank you so much for confirming that. Okay, I want to welcome you to part 2 of multiple linear regression. What we want to do, of course, the other time we started multiple linear regression, situation where we actually have more than one explanatory variable. And another special of multiple linear regression is when you fit polynomial regression. If you look at the assignment 3, question number 2, assignment. Okay, I noticed this. There are some people that actually reach out to me that the image for assignment 2 was not showing. And that was why I extended the deadline for submission by 48 hours. Even though it's showing to some people, but not showing to other people. We use different kind of laptop. So what I'm going to be doing from now is, converting it to PDF and uploading it to the module, just like the way I did assignment 3. The assignment 3 now, the document is on the module. Does that make sense? I know PDF will be visible to everyone. And that was why I did that. I want to welcome you to this topic, multiple linear regression, where the focus today is we want to put into consideration the nature of the explanatory variable, X. The explanatory variable can actually be either categorical or continuous. We can even have the combination in today's title, situation where we have both categorical X and quantitative X. That is what we want to talk about. Okay, in the outline, I'm going to walk you through how do we make predictions in multiple linear regression. Of course, I've walked you through how to make prediction in simple linear regression. How do we do that in multiple linear? Then we're also going to look at the effects of categorical variable and quantitative variable on the response. And I'm gonna take you to an example that you're gonna like. Let's go to football now. I know you guys like football. I like football too. Okay, I can't wait to watch Vikings, right? Okay. Now, can we actually, maybe a sports analyst is trying to look at the role point for and point against play in winning percentage of a particular football club. Okay, we have point for, we have point against. When you take a look at point for and point against, they are all quantitative. You know, before I go into using the example of a situation where the predator is going to be categorical, I first want to start with a situation where they are going to be quantitative, like a point for, point against. Before you go into statistical analysis, you already know point for, okay, will contribute positively to the winning percentage. Point against will contribute negatively, right? Let's look at the effects. We run the regression, LM, you can see the code in R, LM, winning percentage on point for plus point against. We do the summary. Look at what we got. Look at the estimates. When you take a look at the estimate for point for, is positive, but the slope for point against is negative. Is that not expected? That's expected. Okay, so, and let's take a look at the p-value. What if in a situation where I actually want to investigate what is the significance of point for, significance of point against? Of course, if you want to conduct a test, okay, significance of point for, okay, it means you need to test the slope associated with point for. What was the slope associated with the point for is beta 1, so which means you actually want to test beta 1 equal to 0 against alternative beta 1 not equal to 0. And you make use of the test statistics, which is going to be beta 1 cap divided by the standard error. What was the beta 1 cap in the table? It's 0.001, is 0.00176 Okay, for those of you online, talking about this guy here, right? What is the standard error? Divided by the standard error is 0.0001870. And what does that give us? The t value was 9.445. Okay, this is the test statistic value. Now, what is the p value now? The p value associated with that, according to the table, was 2.37. okay, times 10 raised to the power minus 10. This is more or less like a 0.000 something. Now you compare the p-value here now with the level of significance. The level of significance alpha, the level of significance alpha used to be 0.05 under decision rule. When p-value is less than alpha, the null hypothesis will be rejected. When the null hypothesis is rejected, you know what you're trying to tell the world. You are trying to tell the world the slope associated with 0.4 is significantly different from 0. When it is significantly different from 0, you know what that means? That confirms the significance of 0.4 as to winning percentage of a football club. Does that make sense? You can also test for point against. It's also significant. Look at all of that in the table. Now, if I want to look at the overall significance of the parameters, the overall significance, I'm going to look at the F statistic. Do you see the F statistic? 110.9. What is the p-value associated with that? It is 2.598 times 10 raised to the power minus 14. That p-value, it is the p-value of, you are testing the overall significance of the parameters in the model. When you are testing for individual, we make use of a t-test. Individual like, okay, I want to test significance of the slope associated with 0.4. I want to test significance of of the slope associated with point against. I'm going to make use of the t-test, or I want to test the significance of the intercept. I'm actually going to use t-test. But what of in a situation where I actually want to test for overall significance of the model, I'm actually going to make use of F test. And what is the F statistic value? It's 110.9. What is the p value for that? It is 2.598 e minus 14. Does that make sense? That tests the significance of the overall parameters in the model. How do I make prediction now? Go ahead. Okay. Now, if I hear you clearly, why is a magnitude of 0.4 and point against are not the same? Okay, they are not like necessarily going to be the same, because you know why? The estimate that you are seeing there is a slope, is the rate at which the winning percentage changes for any change in 0.4. Maybe you go from this point to this point. How does that change the winning percentage? Okay. Now, when you now take a look at the point against, you see what I mean? Well, what I mean now. So the point against, in fact, it's even negative here. Negative in the sense that, of course, you expect that. So in your question, the magnitude, they are not necessarily going to have the same magnitude. Does that make sense? So the slope can be any value. You see what I mean? So when they are the same, you are trying to say that in the first place, they should not even be in the model together. Because one of the assumptions in multiple linear regression is that two explanatory variables should not have the same influence on the response, which I'm still going to talk about. I call multicollinearity. Okay, we're still coming back to that. In multiple linear regression, it's just that you have two captains in a ship. There's going to be a fight. So we don't expect them to have the same magnitude. So having the same magnitude means they have the same influence. So variables could affect another variable dependent. The moment they have the same effect on that, they shouldn't be together in the model. That violates statistical rule. So I'm just talking from statistical angle. But if I want to go mathematical angle, the slope, the two slope are not necessarily going to be the same. They could be, they may not. But if they are, that's a violation in statistics, which I'm still going to talk about. Does that make sense? Yeah. Now, I'm going to say this. There's something that we call game of emotions, and there's something that we call game of evidence. At times, what we do most in statistics is we believe in what our data say, even though we could have certain perception before we go into the research. We don't expect the perception we have to influence our results. We want the data set to do the job by talking to us. That's what I mean now. So we have, and let me also tell you this: in magnitude, the fact that values are not the same in magnitude does not mean they are not statistically the same. I'm going to say that again. You may be looking at values, right? Oh, is 0.05, is 0.07. Are they the same? No. But statistically, when we investigate, because when we investigate, we are not going to base it on that values alone. We're also going to make use of their variation. And that is why you always see when we are conducting a test, what do we always do? We divide the estimate by what? By a standard error. They may have the same estimate, but they are not likely going to have the same variation. And that's why statistics, we don't look at it from the figure, the values perspective. We conduct a test. Okay, that's a good question. Okay, now, if I want to know, like if you take a look at the p-value now, right, of the overall significance of the model, the p-value that we have, 2.598, E minus 14, is telling us that the model is significant, right? Now the question now is just like it's trying to say, oh, this model is adequate. Then another question? Another question is, how adequate is the model? Like, tell us the degree of adequacy. 1% adequacy is adequacy. 2%, to what percentage? Then you look at the multiple R squared. The multiple R squared, you see 0.8844, right? Is 0.8844. That is going to tell us how adequate is a model. We call that coefficient of determination. That will tell us out of 100% variation in the winning percentage, 0.4 and 0.8 gains explain 88.44%, which means there are still other factors that we did not consider that also explain winning percentage. And what are the other factors here? They are unobserved. We believe their effect is minute. Their effect is very small. And that is why we don't consider them. Does that make sense now? Now, how do we now do prediction? If everything is okay, you can do, there are two types of prediction. You remember what we did the other time under simple linear regression? Okay? There's a, we have points estimate of prediction for individual and for the average. They're going to be the same. But what will be different will be their intervals. Where you see confidence, it's talking about the average. Where you see prediction, it's talking about individual. When you compare the point estimate, it's the same. Like for instance, if a team, okay, if the 0.4 is 400 and 0.8 gauge is 350, what am I doing now? I'm using the model. I'm using the model that I generated from there. The model that you actually generate. Okay, the model you generate. You want to look at the model now. Okay, uh, you know, when PCT cap equal 0.41 72230 plus 0.0017662.4 minus 0.0015268 points against. This is a model. This is a fitted regression model. So what do you think we're doing now here? What we're actually doing here is, okay, when 0.4 is 400, you're plugging that in. When point against is 350, you actually want to make a prediction for the win percentage. So the win percentage you're going to have is going to be 0.58, 0.5893095. Whether if you're looking at the interval for individual or for average, it's going to be the same for point estimate, but it's going to be different for interval. Of course, the one that we have, the range, a wider range of the interval is going to be individual prediction. Does that make sense? Take a look at that. We did that under the simple linear regression. Okay, this is how that is done. We want to go into situation now. We want to go back to look at variables that can explain wage. And with all of us want to start, a very good place to start when you are trying to characterize relationship between variables is to start from simple linear regression. And after starting from simple linear regression, then you're going to be adding. Okay, now let's look at it. Exploring relationship between wage and marital status. Marital status is categorical, right? And when you want to run that, this is what we have. Okay. I told you I've used this example the other time. You can see that the marital status here, we have married, single. In the arrow output, you can see status single, right? R as automatically coded single as 1 and coded married as 0. Don't forget, we did this under dummy regression, right? Dummy regression, right? Okay, and this is interpretation based on the model. A single workers earn 109 cents less per hour than the married workers on average, because the married workers is the intercept here. The married workers is nested in the intercept. The married worker is actually coded 0. Okay, don't forget the y-intercept is the values of y when s equal to 0. In this case, the married is coded as 0, single coded as 1. How do I know? Because in the output, in the arrow output, it is displaying status single. And whatever that is displayed in the level of the categorical variable, that is what the arrow coded as 1. Does that make sense? Okay. We now say that, okay, you know what? How can we improve on that model? Initially, we only use effects of marital status on wage. How can we improve on this model? Can we think of other variable that could influence the wage? And we now come across experience of workers, okay, can also influence the wages of workers. Now, I want you to take a look at this. Experience here is quantitative, but the maritus is categorical. This is a combination of a quantitative explanatory variable and a categorical explanatory variable. I want you to take a look at that. Now, by the time we do that, that is a coding now. If you want to do that, and what was the feeder module? Of course, the feeder module is that. Do you see wage cap 8.86? And I'm just taking that to 2 decimal. You see the estimate to 2 decimal? Take a look at that. Now, what was lacking or what was missing? What was missing here? What was missing here is the experience. When you only fit simple linear regression, where you only consider marital status, then you don't, your experience is missing here. And let me tell you this, when a variable is missing in a model, if that very variable has a connection to the dependent and is missing, then your model will be misleading. I'm going to say that again. When your model lacks relevant predator, okay? When your model lacks relevant predator, okay, we cannot trust your model. Okay, now that was why we were actually incorporating experience. We want to see how whether that will change the trajectory, okay, of results. Do you know that with the model we have, we can say something about married workers, putting into consideration their experience. We can also talk about single workers, putting into consideration their experience. Because let me tell you this, there's possibility that two factors, two independent variables, the effect of experience on the wage may depend on whether the person is single or not. That's why we're incorporating that. Now, what is going to be the model? If I want to get the model, what would be the model? What would be the fitted model for married workers? Based on what I have on the board, I need everyone to focus this board. Okay, I've written a general model. What you can see, wage cap equal 8.86 plus 0.027 experience minus 0.90 status single. Now, they're now asking you a question. What is a fitted model for married workers? What I'm just going to do for married workers, wherever I see status single, I'm going to plug in 0. So when I plug in 0, okay, for married workers, okay, the fitted model is basically going to be wage cap equal 8.86 plus 0.027 experience. What have I done? What is missing? We've plugged in status single to be 0. Don't forget, the marital status is coded 0, 1. 0 for married, okay, 1 for single. Okay, when you plug in 0 into that, this is now the fitted model for married workers. Now, how do we now get a fitted model for single workers? What we're going to do, we're going to plug in 1 in place of the single. So when you plug in 1, so for single now, for single workers now, okay, we're actually going to have wage is going to be 8.86 plus 0.027 x bar, okay, minus is 0.901. You know what's going to happen? This guy, 8.86 minus that. The single workers, we have a different intercept. The intercept here for married is 8.86, but the intercept for single is going to be 8.86 minus 0.9. Even though they got the same slope. Look at that. They got the same slope, but different intercept. Does that make sense now? Okay, that's exactly what I mean. Now, when experience equal to 20, how much less does a single worker earn than a married worker on average? If I want to answer that question, I can come in, plug in 20 for experience, plug in 20 for experience here, and look at the difference. Does that make sense? Now, when experience equal to 40, okay, you can do the same. Now, the model that I have now, okay, tell us how married workers, this one is trying to tell us the experience of married workers to the wage, the experience of single workers to the wage. That's exactly what we mean. Okay, now for any common experience level, how much less does a single worker earn than a married worker on average? If you want to know, that is what I say. In other words, okay, when we control the experience in the first module that we did, where we only consider marital status, we did not control experience. Controlling experience means adjusting for that effect. So if you want to, you say, in other words, when we control for experience, that is, we owe the value of experienced workers, we owe the constant value of experience. A single worker earns 90 cents less than a married worker on average. That is after controlling, and that's exactly what you're saying. Now, and I say, recall, when not controlling, this is what happened. When you did not control, what happened here? 109 cents is what the single worker earn less per hour compared to married. But after controlling for experience, what happened? The single worker will gain. What do they gain? Look at that, from 109 to 90 cents. Does that make sense? From 109 cents now to 90 cents when you incorporated experience. But when there was no experience, what do you say? $1.09 is 109 cents. That was what they had less compared to married workers. But after controlling for experience, you can see it is now 90. It is now what they earn less is now 90 cents. Does that make sense? Okay. And that was why you were subtracting that. Now from that. Now, another thing I want to talk about now. Can we think of more variables that are important to predicting wage? We've considered marital status. We've considered experience. What are other variables that may have a connection? Another variable is years of education. Another variable is the sector a particular worker belongs in an industry or in an organization. Now we want to control for all of that. Oh my God, look at the code now. What do I want to do now? We're looking at the effect of experience, years of education, the sector a worker belongs, the marital status of worker on wage. Using the data set, this is from CPS 1985. You are using this kind of, even this data in the current assignment. If you check the current assignment 3. Okay, now experience, years of experience, years of education are quantitative. Sector and marital status are categorical. So what do you see now? This is a multiple linear regression having the mixture of quantitative explanatory variables and categorical explanatory variables. Let's look at the results. Oh my God, this is the result. I need you to pay attention to this result. Now, you see ESPA Edu, right? You're only going to have one for them, just one, single one, because they are quantitative. They are not categorical. But situation where there is levels, categorical, okay? We actually, is going to be the numbers of levels minus 1. Look at the last one. You see status single, right? it means the numbers of levels is 2 initially. Married, single. Arrow will report 1. Let's look at the one in yellow. The one in yellow, let us count them. 1, 2, 3, 4, 5, 6, 7. Initially, they were 8. I needed to go back. Let's count them. Clerical, CONC 1, 2, 3, 4, 5, 6, 7, 8. But you know what's going to happen? R will automatically reference 1. Does that make sense? R will automatically drop 1. And that one that is dropping is going to be nested in the intercept. Right now, which one appear in the sector here that you don't see in the output? Orders. You see, there's order, right? You want to go back? Look at the sector. Do you see order? Okay. R has coded that as 0. That is why it's not showing. The same way he coded married as 0 and single as 1. And that is why in your module, in your output, what do you see? You see single, right? There are 2 levels. Okay, single is only showing. R has automatically referenced married, coded it as 1. I mean as 0. Now, oh, sorry, there's order here. I think the one that is not here is clerical. Let's go back. Clerical, not order. Clerical, yeah, clerical. Order is there. Clerical. Okay, clerical is not there. How do we automatically choose anyone? Okay, now, based on this now, if I ask you to write a feeder model, okay, I've already written that. I only wanted to fill it, to just fill the gap. The first one, of course, is going to be intercept, right? Negative 3.751. That's going to be there. What will be the next one with the experience? 0.0944. Now you understand how you're going to write that out. Okay? You're going to write a feeder model. Now, let us now check the effect. Let's look at the slope for the marital status now. How, initially we look at the effect of marital status on wages. We realize that single worker was earning 109 cents less per hour than the married. When we incorporated experience, a single worker gained, right? Instead of losing 109 cents, it was losing 90 cents. But right now, we have incorporated years of education, sector. Let us now look at the slope now. Oh my God, look at the slope of the status. Single is 0.34, sorry, is negative is 0.39. 846, let's say like 40 cents. What has happened? The single worker has gained again. Initially, it was losing. It was on 109 cents, like he earned 109 cents less than the married. When we only consider marital status as a factor, when we now incorporate experience, okay, instead of losing 109, it was losing 90. But right now that we incorporated the years of education and the sector it belonged, what is it losing now? Just about 40 cents. That's a gain. And that was why I have this interpretation here. Take a look at the first one. When not controlling for any other labor force factor, okay, single worker make 109 cents less per hour than married workers on average. When controlling for experience only, single workers make 90 cents less. Right now, when controlling for experience, years of education, the sector the worker belongs, the single workers make 40 cents less on average. Look at that. Can you see that? And let me now tell you this. Even though the primary variable of interest was marital status, that was a primary variable of interest. But if we have covariate, we call them covariate. Covariate. The covariates are other relevant explanatory variables that have a connection with the dependent variable. Even though I'm looking at the effects of marital status, I need to adjust for them. I need to incorporate them into the model. Incorporating them into the model if they are relevant. If they are not relevant, I don't need them. And how do I know if they are relevant? How do I know if they are relevant? I'm actually going to look at the p-value. Look at the p-value. The one where if the p-value is less than 0.05, that shows significance. That shows they need to be incorporated. Take a look at that. Even though when you take a look at the status single, the p-value is 0.34564, which means marital status does not even have effect. Whether you are married or not, the salary is the same. What determines the salary is your years of experience. Look at the p-value for years of experience, the slope. It's less than 0.05. Look at the years of education. That is what determines your salary, not whether you are married or single. That is what that is the story this is telling. Look at that. Because the p-value for single here, look at the p-value for the marital status, the p-value is 0.34. That is greater than 0.05. When a p-value is greater than 0.05, that shows it's insignificant. Whether you are married or not. Okay? That doesn't determine your salary. That's what it means. Based on these results, what determines your salary is your years of experience at work, your years of education, and the sector you belong. Does that make sense? That's what it means. Okay. Now okay, go ahead. Exactly. If at least one, I know where you are driving at. I'm saying that the sector sales and sector services are not significant. But if I can identify just one that is significant, I'm done. Sector is significant. That's what I mean. That's a good question. Okay, now if you take a look at this, our major, look at that. The response variable is wage. The variable of interest is status, marital status, but along the line, we incorporated covariate that we believe may be having connection to the response. And look at what I said. Controlling for covariate is especially important when you analyze data from an observational study. We have two types of study, observational and experimental. Observational study is when you conduct survey. You're using, historical data. Okay. Experimental study is when you assign participants to groups, like maybe to treatment group. That's kind of expensive. That's what they do in clinical trial. Observational study does not have a whole statistical power. And because of that, because correlation does not imply causation. I'm going to say that again. Correlation does not implies causation because of what I call a third variable effect. The third variable, when I look at the effect of status, marital status on salary, that is not enough. If there exists other variable that actually affect the wage, and we can see now we've incorporated them. Okay. Now, I think I gave you, this is for when I was talking about single. Okay. And you want to visualize that. One categorical variable, two levels. Okay. And this is when I only consider experience. That is a graphical representation. I'm talking about The scatter plot, where you plot way against experience and putting into consideration the status. Okay, it's like plotting one variable against two variables at a time. Okay, that's what you're seeing now. Okay, take a look at that. Okay, then when you want to visualize the fitted model for experience, education, status single, and I said something here, the number of quantitative predictor determine the shape, because they could ask you to determine what is the shape of the object. When I say the shape of the object, I'm talking about the point, how many lines, how many planes. And what determines that is the number of quantitative predictor. Now, based on this model, how many quantitative predictor we have, based on the one I'm showing, just the number of quantitative predictor is one, status, marital status, based on this. But in the one that I show you, we have marital status and sector. They are two. Okay, so take a look at that. Okay, so two quantitative predictor, okay, plus one categorical. So the one categorical is, when I say two quantitative predictor, quantitative, I mean experience, years of education, plus one categorical. What is that? Marital status. And marital status has two levels: married, single. Okay, and that will be equal to how many parallel planes that we have. I need you to figure it out. If they could have said, I said the number of categorical predictor and the numbers of category level determines how many objects they are. You can use that. So okay, that is going to be the end of my lecture today. Now let me just give you the summary of what we have done today. Example of what we actually did today is just that we consider situation where in our model we could be testing the effect of quantitative predictor and categorical predictor. Okay, and situation where we needed to, even though we're looking at the effect of primary variable of interest, can we also test the effect of some other factor that could be influencing the dependent variable? And the question is, how am I going to know? Of course, you're going to know by revealing literature. If you want to do research, you start from reading articles, okay, for you to be able to know what are the variables that are important. I remember what I did in my capstone project in Africa when I was doing my bachelor program, where I look at the effect of exchange rates, consumer price index, and inflation rate on the GDP of Nigeria. Of course, it means I made use of, you know, uh, more than one predictor. Okay, so which means, why is it that I did not only look at one effect of one predictor? When I look at the effect of one predictor, even though it's a primary main of interest, if I also don't consider other potential predictor that could have effect, then my model will be missing very relevant variable. And when the model is missing a very relevant variable, then that model will mislead. And that is enough to undermine the performance of the model, even if all assumptions are not violated. It is not only assumption that we talk about. Okay, there are some other metrics of evaluation to see why is it that a judge in a particular court will give a verdict and an accused is going to appeal a case in the higher court. There's possibility that higher court can even reverse the judgment, the verdict taken in the lower court. And the person can say, okay, I'm not satisfied with this. I'm going to go to the Supreme Court. We also have superior metric of evaluation of our models, because all what we're trying to do in statistics is to make sure the model we choose at the end of the day, we have been able to prove beyond every statistical reasonable doubt. Is there any question before I go? Like I said, I'm not happy with the midterm one performance because the mean the mean performance was maybe 84. That's not what I wanted. Okay, and if there's anyone among you that is struggling, and I'm repeating it again, summer semester is very, very short. Please visit with me during my office hour. My office hours start at 11:30 a.m. I think Monday, Wednesdays, and Thursdays. You can check the syllabus. You don't necessarily need to come to my office. You can be anywhere in the world to attend my office hour. It's the same Zoom link that we're using in this class. I want to hear from you. Make sure you stay safe and have a lovely day. Bye for now, everyone.
Thank you. See you tomorrow.
You welcome. You welcome.